All right, let's dive in. Today, we're talking about the absolute foundation of artificial intelligence. Seriously, if you want to understand how pretty much any AI works, from your smart thermostat to a self-driving car, you need to get your head around one single, powerful idea: the intelligent agent. So, let me just kick things off with a question for you. What on earth could you, a simple thermostat on the wall, and a super sophisticated, self-driving car possibly have in common? I know it sounds like the start of a bad joke, but the answer is actually the secret key to this whole thing. And the answer is, you're all agents. Now I know, agent doesn't sound very exciting, but trust me, this concept is the fundamental building block for every single AI system out there, from the most basic to the mind-bogglingly complex. So what exactly is an agent? Well, the core idea is beautifully simple. It's just anything that can sense the world around it and then do something in response. That's it. It perceives and it acts. This simple little loop is the engine that drives all of AI. And here's what that looks like. You've got sensors, which are constantly gathering info about the environment. That information gets fed into some kind of control unit, the brain of the operation, which then makes a choice. And finally, the actuators are what actually carry out that action. It's this continuous cycle: see, think, do, over and over again. To make this super clear, think about us. As a human agent, your sensors are your eyes, your ears, your sense of touch. Your actuators, those are your hands, your legs, your voice. A robot is doing the exact same thing, just with different parts. Its sensors might be cameras or LiDAR, and its actuators are its motors, wheels, or speakers. See? It's the same design, just different hardware. Let's go back to that self-driving car. It's a perfect example. It's constantly perceiving the world with its cameras and GPS. It's seeing other cars, pedestrians, traffic lights. Based on everything it sees, it then acts by using its actuators, the steering, the accelerator, the brakes, to get you where you need to go. That's the agent loop, right there on the road. Okay, so we've got a handle on what an agent is, but that's only half the story. We don't just want agents that do stuff, we want them to do the right stuff. We want them to be intelligent. Which brings us to the big question. How do we know if an agent is actually any good? What makes it rational? In the world of AI, a rational agent is simply one that does the right thing. And what's the right thing? Well, it's whatever action is going to make it the most successful based on some goal we give it. We, the designers, get to decide what success looks like, whether it's winning a game of chess or just giving a passenger a smooth, safe ride home. But, and this is a huge but, being rational is not the same as being perfect. There's this fantastic example to illustrate this. Imagine you're crossing the street. You look both ways, you see that it's clear, and you decide to walk. A perfectly rational decision. But what if, at that exact moment, a cargo door falls off an airplane and lands on you? Was your decision to cross the street irrational? Absolutely not. You couldn't possibly have known. And that's the whole ballgame right there. Rationality is all about maximizing your expected success based on what you know right now. It's about playing the best hand with the cards you're dealt. Perfection, on the other hand, would mean maximizing your actual success, which is impossible, because that would mean you can see the future. So rationality is achievable, perfection, not so much. So if our goal is to build one of these rational agents, where do we even begin? Well, you need a blueprint, right? A clear way to define the job you want it to do. In AI, that blueprint is called the PAAS framework. It's how we turn a vague idea into a concrete design. PEAS. It stands for Performance, Environment, Actuators, and Sensors. This is basically the master checklist. It forces you to answer the four most important questions. First, what does a good job look like? That's your performance measure. Where is it going to be working? That's the environment. What can it actually do? Those are its actuators. And what information can it get from the world? Those are its sensors. Let's run our automated taxi through this. P for performance? Well, we want a safe, fast, legal, and comfortable trip, and maybe to maximize profits. E for environment? That's going to be roads, traffic, pedestrians, weather, a messy, unpredictable world. A for actuators? The car has a steering wheel, accelerator, brake, horn, the works. And S for sensors? It's got cameras, GPS, a speedometer, and all sorts of things. See? Once you fill this out, you have a really clear picture of the exact problem your AI needs to solve. All right, so we know how to define the problem. Now let's pop the hood and take a look inside the agent's mind, because not all agents are built the same. We can design different kinds of brains for them, ranging from incredibly simple to unbelievably complex.
You can think about it like leveling up. At level 1, you've got your simple reflex agents. These are super basic. They just follow if this, then that rules. You know, if the car in front hits its brakes, then I hit my brakes. They only react to what's happening right this second. Okay, level up. Now we have model-based agents. These are smarter because they keep an internal model of the world. They have a little bit of memory. They can track things they can't see right now, like a car that just went into their blind spot. Leveling up again, we get to goal-based agents. Now we're really talking. These agents don't just react, they plan. They have a goal, like get to the airport, and they make decisions that will get them closer to that goal. And finally, at the top tier, you've got utility-based agents. These are the most sophisticated. They don't just have one goal, they have preferences. They try to maximize their overall happiness or utility by making trade-offs. For example, balancing the desire for a fast trip against the desire for a safe and comfortable.
So, let's pull all this back together. We've talked about what an agent is, what makes it rational, and the different ways we can build one. Why does all this framework stuff matter so much? Because when you boil it all down, this simple framework, perceive, reason, act, isn't just a part of AI. In many ways, it is AI. From the bad guys in a video game to the most advanced language models we have today, at their very core, they're all just agents, trying their best to do the right thing in whatever environment we've placed them. And this leaves us with a fascinating, kind of mind-bending question to end on. As these agents get more and more sophisticated, especially those utility-based ones that can learn from us, what happens when they get so good that they can perfectly match and even anticipate our preferences? Is that true intelligence we're seeing, or have we just built the world's most perfect mimic? Something to chew on. Thanks for joining me for this Explain.